Oh, I've already done that 2 or 3 times. Yeah, I have. All right, so we're starting a new section called Trig Galore, which will include a bunch of fun topics. As a caution, stay with me early on and it won't seem difficult at the end. When you tend to get behind in trig, it tends to accumulate and become very annoying, and it seems like you are getting dumped on all on a test. But if you kind of stay up with it day by day, it will not seem overwhelming, especially this beginning of the chapter, because you've learned most of this. There are a bunch of definitions right here. This is page 99 in the book, and these definitions, I want you to just scan through them right now and be honest with me and tell me if there's something that you don't recognize and you'd like me to talk about, because I'd rather spend more time actually talking about things that are going to give you trouble that I'm normally rushed at the end with, and I think we'll be better off. So looking at this, anybody see any definitions at all? Don't be as shy. Anything that you're looking at and going, hey, can you talk about that again? Anyone?
Initial side.
Okay, so initial side, normally that's not going to be a huge concern, but in standard position, do y'all remember what standard position of an angle means? I probably should have included that. A-N-G-L-E. Standard position of an angle means your angle is beginning at what degree? 0. So standard position, you've always got your initial side pointed at 0 degrees or 0 radians. Okay? So that's standard position. So when I say initial side, I'm talking about the angle before the rotation of the ray. So since an angle is basically 2 rays coming out of one point that's rotating, most of the time when we see an angle, like if I were to draw an angle like this, I'm not going to look at it and go, what's the initial, what's the terminal, because it typically doesn't matter. If I draw a triangle and you're looking at an angle, I'm not looking at it and going, what's the initial, what's the terminal, because it doesn't matter. Really only in standard position would I think about initial and terminal in the work that we do. And then the terminal means where does it terminate? So if it opened up to say here, we would call that my terminal side. And then of course the angle would either be measured in counterclockwise, or you could also measure it in clockwise, positive or negative rotations. But that's standard position means your initial side is pointed at 0, and then terminal side would just be where you are after the rotation. It's not a huge deal. I can't even think of how I would ask you questions about that, except definition of standard position, just knowing you start at 0 with that initial side. Anybody else on anything that you're just staring at?
With the degrees when it's seconds, are we just going to use our calculator?
Yes, you are. Have I passed that? Is that down here? Yeah, I'll talk about that in a second. But yes, you're only going to have to use your calculator. I did show you how to convert, I believe, manually down here, but that's not something I'm going to make you do. It used to show up at math tournaments back in the 90s, and then it quit showing up. It probably still does in pre-algebra or something like that, but it does not in our course, so I quit asking about it. And I'll show you how to use your Inspire. Do y'all have your Inspire with you? Okay, even if you don't, it's not probably hard to remember, but I'll show you how to use that to convert in a second. Anybody on radian measure? Does yours print out nicely like this? Okay, because I had a printout a second ago that did not cut stuff off. Sometimes when it converts to a PDF, it loses some of its quality, strangely. I remember complementary, supplementary, coterminal. That's one that people forget a lot. Every now and then I'll ask a little question, and I'll give you a couple definitions on a test, and people seem to miss coterminal, and they seem to miss quadrantal. And I don't even know if I put quadrantal on here, I'll mention that again, but coterminal means they what? Co usually means what? Co-captain, co-president. There's 2 things going on, right? So to co-terminate, that means that angle what? Both sides are of the angle terminate in the same place. Co-terminate, coterminal. So if they both end up in the same place, it could be like 0 degrees, it could be like 360 degrees. But anyway, the angles that begin and end in the same place, if I have 2 of them, it could be something like, here's your first one, it's 30 degrees, right? And then you've got another one that looks like 30, but it went this way. So it was negative 330. Or maybe you got another one that looks just like the first one, and maybe it went around like this. All right? So if I have two, I'm sorry, I initially said that incorrect. Two angles that begin and end at the same place, I said both sides, but I mean, when I say both sides, I mean both of those terminal sides end in the same place. Both of these terminal sides. So right here, this could be something like 390 degrees. And what do you notice about coterminal angles? They're all what? What's the difference between these and these?
360.
They're all some multiple of 360 apart. Like this one's 360 degrees more than that one. This one's 360 degrees less than this one. This one's 720 degrees, which is 360 degrees twice. So basically, if you have any angle on the planet and you add or subtract 360 to it, it is now in the same place. Do you remember the story I told you? I think I told you, where I was driving down the road. I was 16 years old. I just gotten my driver's license. You remember this? Yeah, and I'm driving down the interstate and I go under a bridge and I hit a dry spot and I must have been hydroplaning and it spun my car. So I'm driving down I think it's I-85 in Montgomery, and I'm spinning on the interstate going 55 whatever miles an hour in the rain. And I remember I remember stopping, and I remember just like my hands on my steering wheel, I was just shaking because I was younger than you guys. I was still a sophomore. And I remember looking back and like all the traffic had like stopped like 50 yards behind me, like what the heck is going on? And I was like, oh my gosh. So I took a breath and I started going again. And then like 100 yards later, I hit another bridge, spun again. And my tires were just bald. My dad was like, you need new tires, but he wouldn't give me any money. So I finally went and got a couple new tires because they were so bald. But bottom line is, I ended up going the same direction that I was starting with. Like I was heading this way, and then I spun out, I don't remember how many times, it was just spinning. And I ended up going forward again. So my angle, if you think about it, if I was driving this way, initially I was at 0, and then after spinning around a couple times, which is 720, I went 720 degrees if I spun twice. Those are not the same angle, are they? They look the same, but tell me, does 720 degree spin feel the same as nothing? No. Okay, so they're different angles, but because they're coterminal, because the terminal side, whatever, begin and end in the same place, or initial terminal sides are in the same location. Because of that, these angles are coterminal. The trig functions of them will be the same. So like the tangent of that, the tangent that would have the same thing. Or the sine of that, the sine of that. And that's a big deal because if I turn around in a second and say, hey, find the sine of 660 degrees, and you go, oh crud, I didn't memorize that on my unit circle. What I could do is subtract a 360, I could use a coterminal angle in its place to figure it out. And once I get in between 0 and 360, I probably remember, oh, I'm going down a lot. And we'll review that as well. So that's what coterminal is going to be helpful for you for, is actually rewriting it in a different form that looks more familiar to you, whether it's radians or degrees. All right? Anybody else on any of these? We can talk about the calculator in a second, but complementary, supplementary, all that. Okay, let's talk about conversions real quickly. So, if you take out your Inspire, and turn it on, and go to the calculate page. Okay? So here we are. Let's just say I'm going to want to convert, we'll go with 116 degrees, 27 minutes, 14 seconds. So this would be called degrees, minutes, seconds. And I'm going to want to convert that to decimal degrees. Well, the first thing I got to do is actually set it up like this, which is pretty easy on this calculator. First thing I'm going to do is enter the 116. And then I'm going to go down to my pi button. And the pi button is down there at the bottom. See it right by the H? Click on that pi button. And you'll see, oh, there's a little degree sign below the pi. So I'm going to choose that degree sign, hit enter, and there's my degrees. And then I'm going to enter 27, and I'm going to go back to the pi button, but this time I'm going to go past the degree, the radian, the gradient to that little apostrophe, and I'm going to hit enter. And then I'm going to enter the 14, and I'm going to do that pi thing twice. Click, and then pi. And there may be a better way, if you find a better way, like if there's a apostrophe, a quotations, whatever mark somewhere else, show me. I just haven't found it. And then all I gotta do is hit enter, and there's my, that is not right. Make sure that you are in degree mode. Document settings. Degree. Enter. Okay. Go back up there. There we go. So do you see how I had to be in degree mode? If I'm not in degree mode, it goes, oh, he's talking about 116 something else, maybe radians, who knows what else. So I'm putting it in degree mode, and then you can see that it's 116.45 degrees. And that'd be called decimal degrees.
If you click on this button right here.
The book button?
Yeah. No, the button to the left of it.
Absolutely.
I don't. Yeah, I guess.
Oh, there is some right there. Oh yeah, I totally forgot about that. Okay, so even better. Click on the, you see where the book is? To the left of the book, you'll see this little, that's actually the definition of absolute value. Do you see it right by the 9? If you click on the left side of that book, look what you got right here. I don't know why I always forget about this. Look at that, degrees, minutes, seconds. Boom. And all you gotta do is enter 116, 27, 14. So much easier. Thank you. I showed you last year?
Mm-hmm.
Oh. I'm getting old. I had a kid once, he was really bright, works at Google now. He's been there years. But he, I remember he came up with this brilliant formula. I was like, dude, how did you even know that? He goes, your formula packet? I was like, what? And it had been in my summer reading packet I'd handed him for a year, and I totally didn't even remember putting it in there. I didn't remember seeing it. Anyway, information overload. Okay, so what do you do if you want to go the other way? Right? Because most of the time, I guess, you're probably given this. Rarely do you want to go 2 degrees, minutes, seconds, unless you're operating with maps and things like that. Maybe you really want to know latitudinal, longitudinal coordinates, GPS kind of stuff. But anyway, if I wanted to enter a decimal, let's just say I entered something, or I have something like 127, I'm just making something up, 0.643 degrees. And I want to go 2 degrees, minutes, seconds from this decimal degree. So if I want to go 2 degrees, minutes, seconds, that one also is in, but it's on the right side of the book. So check this out. I'm going to go, sorry, let me go. I'm going to enter 127.643. 127.643. So once I put that in there, I don't even have to hit the degree sign. I'm going to hit the right side of the book button. And then I want to use the first book. Now mine's sitting on DMS right now, but yours is probably on an A value, right? So you can scroll all the way down, or watch, you can just hit a letter and we'll jump to it. So like right now I'm on D's, but I'm going to hit F, jumps to F's. I'm going to hit N, jumps to the N's. I'm going to hit R, jumps to the R's, jumps to the T's, jumps to the B's. So when I want to go to DMS, I just hit D and I scroll down to where it says DMS. And that means, all right, arrow to DMS, just hit enter and enter again, and it will change it to degrees, minutes, seconds. So pretty easy with this calculator. Go with me? And that's all I'm going to require of you on that. So as you can imagine, since it's just calculator work, it's not going to be that much of a part of this test. All right, moving through this, even and odd functions. Do you remember these definitions of even and odd? Now you may or may not remember them, but the bottom line is the only even functions, the only even trig functions are the cosine and the secant. And if you think about it, it makes sense, because what this is saying right here is that the cosine of something like negative 30 would be the same as a positive 30. The secant of something like negative 60 would be the same as a positive 60. And if you think about it, look at the unit circle. Like for instance, take 30 and negative 30. Here's 30, there's negative 30, right? Right? The cosine is the x movement, right? Isn't it the same x movement to get to 30 as it is to get to negative 30? So cosine of 30 and cosine of negative 30 are both going to end up being square root of 3 over 2. Because that's an even identity. Now sine is not an even identity. The sine of 30 and the sine of negative 30 are two different things, because the sine of 30 is the y value, that's a half. Sine of negative 30 is the y value, that's a negative a half. Those aren't the same. But if opposite angles on an even function, opposite angles, opposite x's give me the same y's. That's the whole definition of even, right? Opposite x's give me the same y's. And we've learned that before. And you can see, look, opposite x's, the y's are equal. That's only true for cosine and its reciprocal secant. All the rest, odd. Okay? Odd functions say this. Opposite x's do not give me the same y's. They do not. They give me opposite y's. So if one of the y's was negated, then they'd be the same. So opposite x's, opposite y's. Well, look at this. Opposite x's, opposite y's. That's true for all the other trig functions. Now, what does that mean to you? Well, if I were to ask you cosine of negative 120, you can just throw the negative away and make it cosine of positive 120, and then simplify it. And it allows you to use those positive angles on your unit circle. Now, you could also take the negative 120 and do what to it with the whole coterminal thing? What could you do with the negative 120 degree angle? You could add 360 as well. That's another way to go. But you have another option. That's all it's saying. Okay? And then you guys learned the unit circle last year from me. I believe you probably messed around with it a little bit with Homer's as well. So I'm not going to go through all of the why of it, but I am going to show you the how of it again. Do you remember if you have a blank unit circle and you're labeling it? Do you remember the patterns you could go about? First of all, do you know the angles are 30, 45, 60, 90, 120, 135? Does anybody have any issues with the angles? Okay, so once you get your angles, and those would be the positives, the radians are what usually give people a little bit of trouble. So remember at the top, you're going to start with, and I know there are little fractions of little sideways ones, I'm going to rewrite them. 2 on the bottom, 3 on the bottom, 4 on the bottom, 6 on the bottom. And it goes down like that as well. 2, 3, 4, 6. And then starting from down here, 2. I'm just going to cover all this. Well, no. 3, 4, 6, and then coming up this way, 2, 3, 4, 6. And then all of them have pi's on the top. Now at some point you're going to really have to have these memorized, but all of them have pi's. And then the number with the pi is depends on the quadrant. If it's in the first quadrant, what's the number with the pi? 1. If it's in the second quadrant, what's the number with the pi? What is it? Do you remember? 1 less, right? So if there's a 6, there's a 5. If there's a 4, there's a 3. If there's a 3, there's a 2. And then conveniently, the top number follows both rules. It's both 1, like the first quadrant, and it's also 1 less, like the second quadrant. So it follows both. And then coming down here from the bottom, if you're talking about the third quadrant, what are the numbers? Not 1 less, but 1 more. So if there's a 6, this makes that a 7. If there's a 4, that makes that a 5. If there's a 3, that makes that a 4. And if it's in this quadrant, what was the trick? Double it minus 1. So if you double the 3 minus 1, you get a 5. Double the 4 minus 1, you get a 7. Double the 6 minus 1, you get an 11. And conveniently, the bottom number follows both rules. It's either 1 more than the bottom, 3, or it's double the bottom minus 1. So it follows both rules just like the top one does. And then the only things I haven't put in there are the easiest two, right? If I know that this is 0 radians, then if I go all the way around, it's 2 pi radians, or 4 pi, or 6 pi, or whatever. Well, half of a 2 pi would just be a pi. Right? So anyway, that's how you label the radians. And then when it comes to filling in the actual movements, because remember, all of these little every one of these angles, this just represents a special triangle. Special triangle. Special triangle, right? So if you think about the special triangles that we knew, there were only a few values that showed up on them, right? 1, 2, root 3, 1, 1, root 2, stuff like that. Well, once I make all of the radii right there equal to 1, the only values that are left are 1, you could get that as an answer. You could get the square root of 3 over 2 as one of the sides. You could get the square root of 2 over 2 as one of the sides. You could get 1/2, or you could get 0, in order from greatest to least. Those are the only 5 sides on these that can show up once you make the radius 1. Well, some of these are super easy, right? Like, if I go straight to the right, what does that have to be? How far did I go? How much up did I go? 0, so 1, 0. If I go straight up, what are my coordinates? 0, but up 1. So some of the coordinates are going to be really easy to label. It's the ones of the special triangles that you got to be careful about. Well, think about it. If I'm going from 0 to 1, and these are my only movements, this always occurs with itself. Square root 2 over 2 only occurs at the ones that have a 4 on the bottom, or the 45s, 135s, 3 pi over 4s, 5 pi over 4s, or 225s. All of those that angles end in a 5, right? The 45, the 135, or the ones that have a 4 in the denominator. Well, the values are always the same, root 2 over 2, root 2 over 2. And then this is how I think of it. If I ever end up moving a big movement, like this was what I would call a little and then a lot. Whereas this one over here, 30 degrees, would be a lot, then a little. Well, I think of that as a lot of movement, and I think of 1/2 as a little movement. So once you get that straight in your head, look how easy this is. And I know easy is relative, but check it out. To get to 30 degrees, what were my movements? A lot, a little. Square root of 3 over 2, 1/2. To get to 60 degrees, up here, what did I do? A little, a lot. 1/2, square root of 3 over 2. To get to 210, what did I do? Negative a lot, negative a little. Negative square root of 3 over 2, negative 1/2. To get to 270, what did I do? No movement, down negative 1. And once you kind of think of your movements all like this, it's pretty easy to navigate that unit circle. Now, if you're looking over here at what I did, these are your trig definitions. You got to know these. All right, we talked about little ways you can remember them, like some old horse came hopping through our alley. You could do that, or some old hippie caught another hippie tripping on acid. I mean, you can go all day long making up this kind of junk. One that I kind of like is if you write all 6 of them out, you've got oh, ah, oh, ow, ho. That works for me. But at some point, you need to get away from all of the opposite and hypotenuse stuff and start leaning heavily into y's, r's, and x's. Okay? So when you think opposite, you really need to be thinking what? Y values. When you think adjacent, you really need to be thinking x values, and then obviously the hypotenuse and like the radius of the unit circle, the r of the unit circle, those are interchangeable. And then if you're using the unit circle, what's the radius always going to be? 1. And that's the beauty of the unit circle. Because now if I want to know the sine of a certain angle, I don't have to do y over r. I can just grab the y coordinate because the r is 1. And I can just literally walk over here and go y coordinate, 1/2. Right? If I want to know the tangent actually is unchanged because there's no r in there. I'm just going to take the y coordinate, put it over the x coordinate. So if I want to know, hey, what's the tangent at 240? I go down to 240 and I take the y coordinate, put it over the x coordinate. Clean it up. Y'all seeing this? So to give you some practice with it, and I know I've actually given you a bunch of these, but and the solutions. But if you look at all these, all I'm grabbing when I'm asking you about sine of 120 here, the only thing I'm grabbing is the y coordinate at 120 degrees. So I'm not going to pull out my unit circle and go, oh, because I don't have time to fill out a unit circle every time I have to evaluate. Visualize in your head, where is 120? That's 90, that's 120. To get to there, what did you have to do? Left a little, up a lot. And sine is the up part, right? It's the y. So up a lot, square root of 3 over 2. And you're done. 7 pi over 4. Now before you overly think through that, in what quadrant is the numerator's value double the bottom minus 1? Okay, so I have a fourth quadrant angle, and the 4 one, if you think about it, 2, 3, 4, 6. The 4 one is the one where you have the same movement, right? So if I want to know the cosine of that, what's the cosine at 7 pi over 4? To the right, root 2 over 2. Done. I'm not overly thinking about all of this stuff. I'm just having a general idea of movement. Tangent of 210. Where's 210? 180 is right here, right? So 210 is just a little bit down. So what do I use with tangent? For tangent, I do the what? Y over the x. So if I think at 210, I went over a lot, down a little, right? Left a lot, down a little. So they're both negative. So I'm going to put the y first, that's the down. So I'm going to take a negative a half. And then I'm going to use the x, which is left a lot, that's the negative square root over 2. And then I'm going to cancel the negatives. And look, if I multiply by the reciprocal or just cancel the 2's, now I'm here. And then I rationalize the denominator, now I'm here. But can I beseech you to do something for yourself? You ever seen the movie Jerry Maguire? Help me help you, okay? If you are looking at the unit circle, it is so important that you memorize the tangents. And I'm going to show you why in a second. Memorize for your sake that any time, this is for tangent, all right? For tangent. Anytime I take a tangent of an angle, that is one of these tall reference angles up here, or down here, or down here. The big ones that have like a 60-degree reference angle, whether it's 120, whether it's 60, 120, 240, or 300. All of those, when you simplify, you get a root 3 derivative. Now, it may be positive, it may be negative, but you know that tangent's positive here, so it must be negative there. So if you ever see any of these where you're up there high, close to the y-axis, or any of the radian, and you're taking the tangent of those angles, or any of the radian values that have a 3 on the bottom, right? Because 2, 3, 2, 3, 2, 3, 2, 3. Any of those are going to be root 3, except for maybe positive or negative, but that all has to do with the quadrants. And then you save yourself the trouble of having to do all this math. Does that make sense? Now, this was not one that was up high. This is one that was near the x-axis. This was a 210, which is right here. Any of these that have the small reference angles, they're not root 3. They're the reciprocals of the root 3. You saw that in the very end, right? So if you have that memorized, these are all root 3 over 3 derivatives. The only difference is sometimes they're negative, sometimes they're positive. But like before, negative in the second and the fourth. And that's going to be huge in a second when I get to this back page. Now, last thing, actually not the last thing. What happens if it's one of these, it's right dead in the middle? You know, the ones that are radian angles that have 4s on the bottom, or the 45s, the 135s, the 225s, 315s. What are those going to end up being? What do you know about at pi over 4? It's the same movement, right? Root 2 over 2, root 2 over 2. So if you're always putting the same value over itself when you're evaluating that angle for tangent, what do you end up with? Either 1 or negative 1. So all of those in the middle, 1, they're derivatives of the 1 or the negative 1. And then the last ones are just kind of the easier ones, because if you're putting y over x and the point is 1, 0, what do you end up with here? If I went over 1, up 0, you're putting 0 over 1, okay? If you're going left -1, up 0, you're putting 0 over -1, still 0. But what happens straight up? That's 0, 1. So you're putting 1 over 0. What is that? Undefined. So right up here, undefined, and down here, undefined. If you have that memorized, it's so much easier. And then when you ever see a cotangent, if you think about it, isn't cotangent the same thing as 1 over tangent? So the reciprocal of the tangent? So if I ever ask you for the cotangent of the 30, just take that and do the reciprocal. Take tangent's value and do the reciprocal. If I ever say cotangent of the 120, take that and do the reciprocal. And you know the beautiful thing about the reciprocal? The reciprocal of √3 is √3 over 3. The reciprocal of undefined is 0. The reciprocal of 0 is undefined. Now technically that's not true. The reciprocal of undefined is not defined. That'd be like saying, what's the reciprocal of both of them? I mean, it doesn't really have a reciprocal. I just made some junk up. But if you think about the idea of a 0 on the bottom, when you take a reciprocal, it becomes a 0 on the top. Are you seeing that? So if I ever said, hey, what's the cotangent of 210? And I go, oh, 210, that's one of these shallow reference angles. That's a √3 over 3. So at tangent, it's a √3 over 3. So the cotangent would just be a √3. Reciprocal. And that's going to help you in a second, and I think you'll see why in a second. So like right here, cotangent of 225. You can do this. You can go to 225. You can take the x and the y. You can write them down. You can cancel the negatives, cancel the 2's, and you'll get 1. Or you can go, wait a minute. What's the tangent at 225? Oh, 225, it's one of those angles in the middle. It's either 1 or -1. Third quadrant, positive 1. And what's the reciprocal of positive 1? Still positive 1. And you're done, and you really didn't have to think too much. I would really encourage you to memorize those tangents. It's really going to help you. Really, really, really. Okay? So, and then on these, if I said, what's secant of 855? Y'all like the angle 855? I'm not a big fan, so what could we do? And subtracting 360, how does that become helpful? What happens when I subtract 360? I'm finding a what? A coterminal angle. And even though that's a different angle, right? The trig function of it will be the same, so I can use it. So I'm going to subtract 360 a couple times and get it to something usable. And then I'm going to go to 135. And secant is what? The reciprocal of cosine. And cosine's x. So I just basically need to find the x value and flip it. So I go to 135. And 135 is left the same as I'm going up. So I'm going to take that x value, which is -√2 over 2, and flip it. And I normally don't even write it. I just flip it. Because secant is 1 over that x value. So flip that x value. So I would normally start here and then just rationalize. And for something like cosecant, this one's a little dirtier. Guys, listen, you don't see a lot of this except in pre-cal, but right here, what do you do with the ugly looking cosecant like this? A second ago, you subtracted 360s because they were degrees, but if it's radians, you're not subtracting 360s, you're subtracting 2 pi's. And 2 pi's, find the common denominator, bam, 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 you're left with this. A little trick that I use a lot of times. If you just change this to an improper fraction, 7 1/3, it's easy to subtract off 2's from 7 1/3, right? Subtract 2, subtract 2, subtract 2, 1 1/3, which is 4/3. So that might get you there quicker if you think about it as an improper fraction, but either way. And then now I can do this. And where's 4 pi over 3? Remember the 3's? 2, 3. So third quadrant, because it's one more. Starts at the bottom, 2, 3. So that's like 240 degrees, right? Now you don't have to change it to 240. But if I'm trying to find the cosecant's related to sine. So instead of using the y value down there, I'm going to do what with the y value? Flip it. Now I can write 1 over y. I can take the y value and put it there, or I can just grab the y value and flip it and go straight to here and then rationalize. And then in calculus, we are going to go, hey, did all that stuff about rationalizing? Guess what? Just kidding. You don't need to bother rationalizing anymore. I don't know why. At least not in AP Calc. Maybe back in college they'll make you. Okay, so I've given you a blank unit circle if you want to practice I'm gonna be honest with you, I'm probably not gonna give you a quiz. You don't have it? You don't have a blank and circle on it? Oh, you do, okay. You can fill it out and practice it. I don't see me giving you a quiz this year on it because it's impossible to do that for my virtual kids, you know, and honestly get something from them that's not just staring at the thing and looking at it. So I'm cutting back on a lot of the quizzes, but you really ought to make sure you quiz yourself and check and make sure you're good. And then I'm giving you this worksheet, and at the very beginning, I'm just trying to give you some practice on 1 through 6, give you some practice, so like understanding how to simplify expressions if you put the y and the x in there, okay? Although you're not going to have to do that if you have tangent memorized. You're not going to have to do y's over x's because you're going to look at this and go, oh, that's negative root 3 over 3 at that angle that would have given me this. Or you're going to know that that is negative root 3 at that angle that gave me that if you have it memorized. And then right here, me asking you the reciprocal is just a shortcut because you're going to be finding these values and then flipping them. So if I want the reciprocal of this, you can take the time and do this and then flip it and then rationalize and then see that that's a 2 which cancels with that. You can go through that, or you can start realizing, oh, root 2 over 2 is root 2 when I flip it. Negative root 3 over 2 is 2 root 3 over 3. Negative 2 root 3 over 3 when I flip it. If I flip a 0, it becomes an undefined, and if I flip an undefined, technically it's not anything, but what would it become when you're thinking about it this way? 0. And knowing that will save you a little bit of time. I don't think you're going to have trouble flipping 1s. But again, those are the only values that show up on the unit circle, right? These right here. And then I don't think you're going to have any trouble flipping a 1/2. So here's where the rubber meets the road, and then we've done a lot of these, and then I'm going to jump to 9:20. I'm going to do this for a couple seconds. I'm going to let you pick any 3 on here, and we'll quickly go through them. Anyway. 18. So tangent of 3 pi over 2. So what's going on at tangent of 3 pi over 2? That is straight down. Well, if you memorized your tangents, straight up and straight down on a tangent is what? Undefined. I've memorized that. I don't have to think anymore. Now, if you don't have it memorized, then you're going to have to go, okay, straight down. My coordinate straight down was 0, 1. And tangent is y over x. So 1 over 0, oh, that's undefined. So I can do it that way if I want, but it's more time than I'm going to spend because I have them memorized. Pick another one. 24. Cosecant of 45. So at 45 degrees, what do I know? What are my coordinates? Root 2 over 2, root 2 over 2. That's the angle's coordinates. And what is cosecant? It's the reciprocal of the sine value. And the sine value I find by doing what? Grabbing the y coordinate. So all I have to do is flip the y coordinate to find that value there. Now the hard way would be to go 1 over root 2 over 2 and then flip it and get 2 over root 2. I'm just going to grab the y value and flip it and then rationalize. And if you already have memorized that the reciprocal of a root 2 over 2 is just a root 2, then you'll save yourself all of this trouble. And you'll go, oh, reciprocal of that, root 2. Some of these things are just worthwhile when you're having to do so many things. Pick something else, but pick a trig function we haven't done yet. Then cosecant, cotangent.
13.
What number?
13.
13. So cosine of 5 pi over 6. So 5 pi over 6, we know that that is, if you think about it, 2, 3, 4, 6. It's almost at the x-axis, right? And my coordinates are what to get there? Left a lot, up a little. So left a lot, but yet positive a little. And cosine is the x-coordinate. I grab the x-coordinate and I'm done. If that had been a secant, I grab the x-coordinate and I flip it. If that had been a tangent, I already know that low-line tangent angles with small reference angles are what? Not root 3s, but root 3 over 3s. They're a little smaller. So root 3 over 3s, but it would have to be negative because it is in that second quadrant. And then I will pick one. How about 35? So 35. I'm dealing with cotangent. Where's negative 60? Negative 60 is right there, right? Now, rather than have all this memorized and take the coordinates and put x over y, which is totally your right, if you want to do that, you could say, okay, this coordinate is right a little, down a lot. 1/2 negative square root of 3 over 2. And according to my definition of cotangent, it's x over y. I could put that x coordinate over that y coordinate, cancel the 2's, that gives me negative 1 over root 3, rationalize negative root 3 over 3. And that is an option for you, and that is a lot of writing and thinking. Another option is to go, what's the tangent there? What is the tangent at a negative 60 at a big reference angle? The one's going big high or big low? It's a root 3 something, right? But it's in the fourth quadrant, so it must be negative. Well, if tangent is a negative root 3 there, cotangent is its reciprocal, and I can jump right to that and rationalize. Or even better, if you know that the reciprocal of root 3 is root 3 over 3, bam. And I got to skip all of that junk. Are y'all with me? Now, you may look at this right now and go, Mr. Hurd, I just don't see memorizing that as being all that helpful. Okay. So you say, look at this last page. Now what am I giving you? Now I'm not giving you trig expressions. I'm giving you trig equations. And I'm asking you, hey, in 0 to 360, in one revolution of the unit circle, what angles would have these values? Now, this is easy on number 2. On number 2, I'm basically saying what angle on the unit circle would have a blank value of square root of 3 over 2? What is cosine linked to? X. So where in the unit circle do I go right a lot? I go right a lot and up a little at 30, or I go right a lot and down a little at either negative 30, but that doesn't fit in there, so I guess I would have to go with 330. And now that was easy, right? Or relatively easy. We used our knowledge, we were okay. And even on this, what about cosecant of 2? You could even go, I'm not a big fan of cosecant. So I'm going to take the reciprocal of both sides, and the reciprocal of a 2 becomes a 1/2, and the reciprocal of a cosecant becomes a 1 over cosecant, which happens to be a sine. And I immediately now have a sine equation. And now I can ask myself, okay, where would sine be a 1/2? And sine's linked to what letter of the coordinate? Y. So where do I go positive a 1/2 or up a little? At 30 again, or also at up a little would be 150. Not down a little, right? So you're going up a little there or up a little here in the second quadrant, so 30 or 150. Are y'all seeing this? Yes, no? But here's where it gets a little tricky. Jump to number 9. Now, what coordinate is tangent linked to? Y and x. Now, what y-x combination gives me root 3 over 3 when it's all simplified? That's where it's trickier, right? Because it's already been simplified. But if I already have memorized, wait a minute, at what angles did root 3 over 3 occur? Remember, root 3's were the big angles. Root 3 over 3's were the smaller angles, right? So which angles had positive tangent values? Where does tangent end up being positive? First and third. So I know right now, oh, it must have been right there then and right there. So it must have been 30 degrees and 210. Are y'all seeing that? That's huge if you have that memorized. How about this? Where's cotangent undefined? Well, I'm not a big fan of cotangent, but I do like tangent. Cotangent undefined, couldn't I take the reciprocal of both sides and get undefined reciprocal is 0? Not really, but work with me, right? Reciprocal of cotangent is tangent. And where did we memorize that tangents were 0? Side to side. Undefined up and down, side to side 0. So, where would these angles be? 0 and 180. Hey, and be careful. Some people write 360. Why doesn't 360 work? Just says less than. All right, so you can only put angles that make this thing true. So even though 360 and 0 are coterminal angles, they are different, right? Right? If not, spin around real quickly and see if you can feel anything, right? It's a difference. What about something like cotangent equals 1? Well, take the reciprocal of both sides and I get tangent equals 1. Now, where is tangent 1? Where did we memorize that? In the middles, right? So it's positive 1 in the first and the third, so what would those two angles be? 45 and 225. Isn't that great when you have those memorized? You just don't have to think about y and x anymore. If you don't have to think about y and x anymore, it's one less trouble. I know I'm doing a lot with tangent. Look at 14. The hard way would make you have to go, what angles, y value over x value, happens to cancel and leave me this? The easy way is going, wait, I memorized tangent. Where was tangent a negative root 3? Remember we said it's root 3's up high, right? But negative would be second and fourth. What are those two angles? 120 and 300. Done. Isn't that nice? I think that's nice. And again, don't write negative 60. It's not because negative 60 wouldn't work normally, but because they gave you that defined region. And I know a lot of people get in their heads, they're like, wait a minute, negative 60, that's between 0 and 360. If I asked you that question 4 years ago, 4 years ago, you're in 7th grade, and I went, hey, is negative 60 in between 0, and we were just talking about numbers, in between 0 and 360. No 7th grader on the planet would say yes. Are you with me? So even though it's in the right location, it isn't in between there. You would have to say, wait a minute, the coterminal angle 300 is, you can use that, but don't say negative 60 if that definition was given that way. What about this? Where does that occur? Where is cosine square root 2 over 2? Cosine's x, right? Where do you go positive the same amount as you go up? Or positive the same amount as you go down? It's just positive. That's all you know. Positive x. 45 and 315. All right? 45 and 315. What about 23? Secant, undefined. Well, again, anytime I see a secant, a cosecant, or a cotangent, I don't much care for them. So a secant undefined would be the same thing as a cosine what? At 0? Where would cosine be 0? Where's your x movement? Not a movement. Straight up, straight down? So 90 or 270? And you'll notice I'm writing all my answers in degrees. I could have used radians, except again, they said give me the answers between 0 and 360 degrees. So I'm using degrees.
Can we have an assignment sheet?
You may, yes, thank you. Oh, and I'm going to tell you something. I am forced by our school system to keep putting everything Monday, week of blah, week of blah. I'm going to begin very soon because I've got to find more time in my life. I'm spending, I think I've said this a million times already, but between 60 and 70 hours a week, I've got to find a way to simplify my life. And I'm spending about 10 hours a week just formatting my Schoology course. So I'm going to very soon, it's going to look more and more generic as we move on. You're going to pull up the week. We're going to go by this. On the week, it is literally going to say, on Monday, refer to your assignment sheet. Now, I'm going to have my homework assignments in there for now. At some point, I might even just have all the homeworks at the bottom and you just go and grab them. But I'm going to try to do as much as I can, and especially over the next 2 weeks because I've already done it. It's already been formatted. But I'll remind you in a couple of weeks, it's going to probably look less and less. We're going to be more and more of this. You guys handled this great last year doing this. You don't need to be babied with that day-to-day thing. Are y'all good with this? Yeah, it just drives me nuts. They're making me do this because some teachers are unable to make a coherent Schoology page. And I know that because my kids went here and they're like, Dad. Like my daughter's favorite teacher last year, and actually she had her many times, one of her favorite teachers was like all over the place. Like it's like, One day it's over here, next day it's over there, it's impossible to keep up, so I get it, but anyway, y'all have a great day. See you, man. Oh, yes, thank you.